Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Pythagorean Identity, and Double Angle Formula. Question 5, the sine of 2 theta equals radical 3 over 2, and the cosine of theta plus sine theta squared. If you're interested in ordering this complete cram session, email me at memedicine@gmail.com for pricing, and also inquire about other subject areas. Let's delve into the problem. Review question 5. If theta is a positive acute angle and the sine of 2 theta is equivalent to radical 3 over 2, then the cosine of theta plus sine theta squared equals 1, 1, 2, 1 plus radical 3 over 2, 3, 30 degrees, or 4, 60 degrees. Definitely press pause and formulate your answer. Okay, so come up with a solution. I'll give you some time to do that. All right, so hopefully by now you're able to come up with a solution, but if not, that's completely fine. Let's solve this together, okay? So let's start here. The cosine of theta plus the sine of theta squared can also be written into its factors. So we have the cosine of theta plus sine theta times the cosine theta plus sine theta. Okay, so we're just breaking this down a little bit. And if you FOIL the terms, that is, you multiply the first, and then you multiply the outside terms, and you multiply the inside and the last terms, you're going to get this. So this expression is also equivalent to the cosine of theta squared. Okay, and I think I should be writing the squared, I don't know, right here when there's no parentheses, but let's just pretend there's a parentheses around this entire thing, alright? My bad. And now you're going to get 2 the cosine of theta times sine theta, because when you multiply the inside terms and the outside terms together, you get cosine theta times sine theta, but you're going to get this expression twice, okay? Now let's multiply the last terms. And so you're going to get the sine of theta squared. And just pretend that there's a parentheses surrounding this, because the square doesn't apply to theta per se, it applies to the entire expression, okay? Alright, so hopefully you're not worn out by now. And the next thing that I want you to do is recall something, okay? I want you to recall the double angle formula for the sine. So the sine of 2a, or the sine of the double angle, and that's equivalent to 2 the cosine of that angle times the sine of that angle. Well, here we see the same format, okay? So what we're going to wind up doing is substituting the sine of 2a for this middle term right here, okay? And that's looking, well, the sine of 2 theta, because this is just the general formula format. And that's looking really good because we have that information. And I also want you to recognize that the cosine squared theta plus sine squared theta equals 1. This is what this should really look like up here, okay? So just pretend that this is written here, okay? And that's nice because we have the cosine squared theta and we have the sine squared theta. And we can just combine these and substitute 1. So after performing our substitution, we get that 1 plus the 1 plus basically the sine of 2 theta is equivalent to the expression, the cosine of theta plus sine theta squared in this particular problem, okay? So our correct answer choice is going to be answer choice 2. Alright, so just gather yourself and hold your breath, because now we're going to delve into the graphing calculator solution. And you could definitely have saved time on this particular problem if you notice something. Well, we're told that theta is a positive acute angle, okay? So if you recognize that this is actually the sine of 60 degrees, you would have been able to interpret that theta is actually going to be 30 degrees. And you could use your graphic calculator to solve accurately and easily, because 30 degrees is a positive acute angle and it occurs in quadrant 1. Therefore, using your calculator is easy, but it's trickier, not difficult, to use your calculator for problems like these if the angle doesn't occur in quadrant 1. It's not difficult, it's just trickier. So let's start to delve into the calculator solution, okay? So the first thing you want to do is ensure that you're in degree mode. So this demonstration is going to be for the TI series, but if you have a Casio or any other brand of calculators, that's fine as well, because the keys might be a little different, but the concept is still the same, okay? So when you press mode, this screen will pop up, and you're going to have your cursor flipping over normal. So what you're going to do next is press the down arrow, then your cursor will be flickering over float. You press the down arrow once more, then your cursor will be flickering over radians, okay? But let's just pretend that the radians is highlighted instead of degrees. What you would have to do then is press the right arrow, and you'll be in degree mode. You don't have to press the enter button to lock into degree mode. All you have to do now is press second mode to quit the screen, okay? And then you're back at the home screen. Alright, so hopefully you're following. This is really not that bad. There's just, a lot of steps. But after you do this over and over and over again, it becomes really easy. It becomes second nature. The next thing we're going to do now is input the inverse sine of radical 3 over 2 to find out what 2 theta is equivalent to, which, it's already shown here. Just pretend that it's not. So you press second sine to pull up this function, and then it automatically comes with an open parentheses. Then you're going to press second x squared to bring up the square root function, and that's also loaded with an open parentheses. And then you're going to press 3 and then close the parentheses, okay? I don't have that shown here, which is not good, but you should have basically closed your parentheses. So let's just put a closed parentheses right here. Alright, and then you're going to divide that by 2. So you're going to divide the square root of 3, or you're going to divide radical 3 by 2, and you do that by pressing the division button and 2, and then close the parentheses, okay? And then you press enter, and you get 60, okay? Which we previously discussed before. Alright, the next thing you're going to do is divide 2 pi by 2 to figure out what pi is. And this is done by basically pressing second, the negative sign, and these keys equate into the previous answer. So that whatever answer you got before, that's what these 2 keys pressed in this sequence loads. Then you're going to divide this by 2, and then you're going to get pi. So 30 is indeed a positive acute angle. Okay? See, I told you this isn't that bad. And so you press enter, and then the 30 is loaded. Okay? So the last and final step that you're going to do, which may be the longest, but it's not the hardest, just have to keep things neat, is you're going to figure out the cosine of theta plus the sine of theta squared. Okay? So first what we do is open up our parentheses, then we hit the cosine function, which comes already loaded with its own open parentheses, and then you're going to hit second negative sign to load the previous answer, which is 30 degrees or theta. Then you close out that parentheses. Then you're going to add the sine, so you press the sine button, which again comes loaded with its own open parentheses. You hit second negative sign again to load the previous answer, which was 30 degrees, or the theta that the question is inquiring about. Then you close out the sine calculation. Then you wrap up the entire expression, and then you're going to press x squared to square it, okay? And then you hit enter, and basically you get this. And your calculator does have a function to turn decimal numbers into fractions, but because this does contain a radical, it wouldn't be able to properly interpret it. So what you would have to do now is plug and chug. You would have to, well, first of all, you can do process of elimination, okay? I'm going to show you how. Because we know that 1.866 is greater than 1, so it's not this. And we didn't get a 30 or a 60. So, yeah, 2 has to be the answer, okay? Alright, thanks for tuning in.